Hello, and welcome to everyone to today's e-showcase, How Utilities Optimize Wastewater Networks with Digital Water Management Technology. Brought to you by Xylem. Let's solve water. Without further ado, I'm going to begin today's presentation.
Thanks for joining us for this panel discussion entitled How Utilities Optimize Wastewater Networks with Digital Water Management Technology. I'm joined by a fantastic panel today, and we're going to talk about their experience of implementing digital tools and techniques to solve some tricky wastewater networks problems. My name is Stephen Pandon, and I'm the Global Practice Manager for Smart Wastewater Networks at Xylem. I have an expertise in sewer overflows and sewer overflow management. I was at Thames Water here in the UK for around about 10 years. And I spent an awful lot of time in asset management and operations, looking after their extensive network, which covers London and the southeast of England. So with that, I'll hand over to our panelists to introduce themselves and we'll get the discussion underway. Kieran.
Thanks, Stephen. I'm Kieran Fahy. I'm with the city of South Bend, so South Bend, Indiana. I'm been here with the city of over 5 years. Before that, I was with the Irish EPA. Worked at the Environmental Protection Agency in Ireland for over a decade. And then some other experience in relation to local government. I worked for local government in Dublin as well, and for the Irish government. So been on this side and working with the environmental enforcement and environmental compliance side for almost 20 years.
All right, I'm Nicole Pash. I am the Client Solutions Manager with Xylem in the Great Lakes region. I work in the digital solutions team. But previously, I worked for the utilities in the city of Grand Rapids, Michigan. Primarily in wastewater, but also drinking water, stormwater, air quality, energy, lighting, and communications. Actually, my last role was focused on connected utilities, building connected communities.
Thank you.
My name is Stacia Eckenweiler. I am in the city of Columbus, Ohio, and I'm with the Columbus Division of Sewers and Drains. I'm the assistant administrator here. I actually just started here a few months ago, but I've been with the city of Columbus since 2011. I was over in our drinking water division prior to this. I oversee our wastewater treatment plants, our compost facility, and our treatment engineering group here in the Division of Sewers and Drains. And previous to the city of Columbus, I spent about 10 years in the engineering consulting world.
Thank you. Okay, so at a global scale, discharges from sewer systems resulting from hydraulic overload are becoming ever more common. And it's a real pressure on utilities in all sorts of jurisdictions and on regulators as well to manage this. There's urbanization and urban densification putting pressure on systems, and probably most importantly, the impact of climate change causing more frequent high density rainfall, putting increasing pressure on the system. Coupled with that, citizens and customers have greater expectations of what these systems are meant to do and are becoming less tolerant of discharges of wastewater to the environment. So just to add some context, and I'll go to you first, Stacia, can you just describe your city's specific wastewater network challenges and where you're focusing at the moment?
Sure. So the major challenges that the city of Columbus faces are quite similar to the challenges that are facing many other older US cities. And that's that during these rain events, our collection system becomes overwhelmed due to the large amounts of stormwater that are entering our sanitary sewers in a very short period of time. So ideally, wastewater flows would be conveyed to our treatment plants via our sanitary sewer system, and then our stormwater flows would be conveyed to our local waterways via our stormwater sewer system. So, but with Columbus being an older city, there are some parts of our system that actually only have one type of sewer that accepts both sanitary and storm flows and takes them all to the treatment plants. We call these combined sewers. And that was just the common practice at the time that those particular areas were developed. So these instances of the sewer system becoming overwhelmed, they come with consequences. Some are in the form of intentional flow relief points into nearby waterways, which we commonly call overflows, or unintentional relief points that may happen in the form of sewer backups into basements of local residents and businesses. So our city's challenge becomes managing these influxes of flow while minimizing the impacts to both the environment through these overflows and to our customers through things like the sanitary backups. And in our separated system in particular, our focus here in Columbus is to try to eliminate the ability for stormwater to even enter the sanitary sewer system, on top of actively managing the flows within our system during these wet weather events.
Lovely. Kieran, how does that compare to South Bend?
Very same, really. You know, wearing different hats, you kind of think as a member of the public, when you hear about these kind of things, you think, isn't it crazy that in this day and age that we're still sending sewage to the river? It should be, you know, the average person on the street will think that that should be something that stopped 100 years ago. But when you hear then about the idea that how much it's actually going to cost to end this, this from happening, I mean, it's costing, and it's the most vulnerable cities in the country, especially like in the States, that have been affected by this, because it's the older communities, the ones that were, you know, the East, the Midwest, these old communities, the Rust Belt, like the people call it, that don't have a huge amount of infrastructure or a huge amount of ability to upgrade their infrastructure. They don't even have the ability to maintain a lot of their infrastructure at the moment. So the idea that you can continue to invest this kind of, you know, the massive money that's really needed to end this process is just, it's a massive problem. And it's one of those things that not a lot of people are aware of this, really, but you talk to different groups across the country over the last couple of years in this role, and so many people are just, you know, aware of, like, why can't we have this, you know, the bigger picture of, like, what are the water problems, and they don't really know about some of the very tangible, the real problems, like combined sewer overflow, and the amount of E. coli and pollution that sends to rivers. And we're a small city here in South Bend. We're just 100,000 people, but up until a couple of years back, or just over a decade ago, before we started to go down a route that's been very successful for us, of a smart sewer route, we had, for 100,000 people and 40,000 households, we had like 2.5 billion gallons of sewage going to our river every year. And when you think about, that's the river that is the reason why South Bend has been built here. It's no way to respect it, really. So the conundrum and the real question is, how can you, on one hand, tackle this problem of sending all this pollution to the river, on the other hand, having almost no resources to not only invest in the future, but to actually maintain the infrastructure that you have. So it's a very, very real problem. And even though it's not the most glamorous of problems, it's very, very real. And luckily, you know, there's a lot has happened in the last couple of years to be able to address that. And that's kind of what we're here today to talk about.
So just building on that, Kieran, South Bend, I'm not wholly familiar with the city. How does it relate to the river that you mentioned it's built on? How do the community there use it, and how does it affect life in South Bend?
So it's interesting because South Bend, one of the reasons why South Bend is here is because it's kind of a link between the Great Lakes and the Mississippi watershed. And there was an area around here where people used to be able to, the Kankakee River is on one side of South Bend, and the watershed is, which is ultimately Mississippi. And then a couple of miles away, you got the St. Joseph River. So the two main watersheds meet here. So it was a big trading post years ago, and one of the reasons why the city developed here. And then it was the reason why the University of Notre Dame developed here. So that was, you know, and it was used for all different processes that you'd hear about. You know, initially there was mills, and people used the energy from the river. But then as the city started to develop, the river was used as basically, we started to build these sewers, and the sewers were just directly depositing into the river. And then we started to turn our back on the river, literally. You know, the main street of South Bend doesn't face the river. We had never embraced it. You only see buildings that are in the last couple of years that actually have embraced it. There's almost no, I think it's just literally just one, and it just closed down recently, one bar restaurant downtown that you could actually sit on and look out at the river. So it was kind of, you know, it's strange because communities developed here, and South Bend is 150 years old, and it was because of the river. And then we started to use it and dump it, and then we kind of turned our back on it. It became this kind of unsightly kind of a mess. And now we're kind of realizing, not just now, but we have done for a number of decades, that we needed to kind of readdress that. So, but the problem is, how do you solve the problem that when you've invested, you've built infrastructure that is ultimately designed to dump into the river? How do you change that? And it's not an easy solution. A lot of dollars.
Yeah, it's trying to solve some real legacy problems, and just building larger, ever larger assets and building bigger pumps isn't going to help necessarily.
Exactly. You can't blame the people who designed the systems in the first case, because like Stacia was saying, the systems were built, they have to have a release. You can't just have, because you can never control the amount of rainfall that's going to fall. You can't say that you can ever build a big enough sewer system, especially a combined sewer system, because you can never say, well, rainfall is never going to exceed this. When I moved to South Bend 5 years ago, looking back at the rainfall data, we always had like 35 inches of rainfall, 30 to 35 inches. And in the last couple of years, we've had, 59, 58, 60, 63 inches of rainfall. So, obviously, if you build a system that doesn't have the release bin, the overflow point, you're going to get the point the station made. It's going to come up in people's basements. It has to come up somewhere. So, kind of sending it to the river was the best of many bad options, I suppose, at the time. But they needed to. We can't blame the people that designed them like this, because at the time it was considered to be a solution, and we're just trying to say, well, it was at the time, and it allowed communities to develop. And now we've got a different approach to environmental protection and management, and we just need to relook at it.
Yeah, it also points out that wastewater infrastructure is very different to other types of infrastructure you find in a city. Is if it stops working, it can affect people in quite a significant way. But not necessarily in a way that people would recognize. It's not a traffic jam, for example, that affects a wide area. That might be a few houses that suffer that backup or that flooding that you described. So it's sort of hidden below our feet, and we don't necessarily realize how important it is until something goes wrong. So Nicole, how does that sort of play with your experience and with some of the other cities that you're currently talking to, particularly that relationship with the water environment that Kieran described?
So my, territory is in the Great Lakes. So, Kieran's right there with me. And, the city of Grand Rapids is right there. And so a lot of these discharges feed into the Great Lakes. And we have an even stricter policy to protect them, a greater, mission, if you will. And so there's more and more work being done. And like Kieran mentioned, this is the Rust Belt. We went through some really tough times. And affordability and equity play huge roles in these programs. And so that's kind of where we're looking at smart sewers and trying to really figure out, where does the investment need to be made? How can we use the infrastructure that we were given? It's kind of like I tell my kids, you get what you get, and you don't throw a fit, right? So how do we take that infrastructure and do the most with it? Use it smarter, optimize it. Where do you put sensors? Where do you do your I&I mitigation, your sewer lining and whatnot? And so that's kind of where we're all driving and going, is not just, can we build a tunnel? Can we, build a bigger system? Because that's not affordable, and it's causing bigger community problems than it solves. And so we're looking at different solutions. Grand Rapids separated. We were fortunate enough to have some leadership way back in the day that went through that process. And instead of maybe delaying our process and delaying our work during the economic kind of depression, if you will, recession, we actually started working harder and faster. Our city leadership said we need to keep people working. We need to keep infrastructure work going. Money is cheap. And so we actually got our system separated years in advance of the deadlines for that reason. Then we realized that all of our work was in certain areas of town, because that's where the separations needed to happen. And we started down the path of, wow, we only built up areas of our community that were maybe more affluent than others. And we didn't do work in that equity-based planning, and how do you look at it in different ways? So even when you think you're doing the right thing, there's always a bigger picture, and there's always a bigger way to connect them.
Which is a really interesting point. There are obviously lots of opportunities to improve the way a system works, particularly at a city scale. But in terms of the specifics of digital solutions, are there any areas that you're focusing on and in Columbus, Stacia?
Yes, absolutely. So our program has actually included a handful of various activities to help us manage the flow in our sewer systems. But the newest and most innovative of these activities is what we're coining real-time control of our sewer system flows, the common discussion item that we're talking here today. So this concept of RTC, I'll call it to abbreviate it, and it includes the use of data that's actually collected from our system, and it helps us provide real-time automation of various control structures within our system. So control structures that may have previously been manually automated or just set and left at that particular point. So here in Columbus, we've been capturing data in our system, like flows and levels, as well as rainfall data for the area overall for decades now. And this data has been input and used to calibrate our sanitary collection system model. And it's helped us to understand the constraints of our system, the way our system responds to these various wet weather events, and just overall system performance. And we've also been able to use this to, as a prediction tool for looking at future wet weather events and how those might actually impact our system and where we need to potentially identify improvements or patterns of how we change where we send flows to at certain points during a wet weather event. So this data collection and then this use of these real-time controls has been the backbone in developing these decision points that we're actually going to be programming into our system in the future, and that should reduce the need for manual settings adjustments and constant operational oversight of our system during wet weather events.
Is there anything, so you mentioned earlier around working upstream of your sewer system as well. So you're working on sustainable drainage kind of implementations in Columbus, I understand. Can you tell us a little bit more about that, please?
Yeah, absolutely. So in addition to real-time controls, we actually took, I guess what we're calling an integrated approach here in the city of Columbus. And previously, we had developed a wet weather management plan back in 2005 as a part of our consent order requirements. And that was chock full of just gray infrastructure in general. It was just, let's add the volume, let's just collect the flows, let's just try and, grab everything we can underground and then get it to our treatment plants. But we took a look back at exactly how that was going to work within our system and realized that it just wasn't going to solve all the problems that we had. So we came up with this integrated plan, and that not only employs the use of some gray infrastructure and some general traditional engineering practices to collect the flows that we just can't reasonably handle within our system, but we've coupled that with this real-time control automation of our system. And then we've also taken a step back and looked at how we can manage the flows before they actually get into our system. So for areas of our particular collection system that are separated, we're trying our best to keep the flows, the stormwater flows, out of our sanitary sewer system as best we can. And so one of the ways that we've done that is employed a lot of green infrastructure throughout our system. So we're trying to collect those stormwater flows, attenuate them, help clean them, and then that also keeps them out of our sanitary sewers and helps beautify our neighborhoods as well. And so all of those things together have helped us develop what is our integrated approach overall to managing the flows in our system.
I like the idea of integrating, particularly around new ways of doing this, whether it's digital or whether it's, as you put it, beautifying your neighborhoods with water management techniques. That's a benefit for in lots of different ways beyond water management, which is really cool. How does that compare with South Bend, Kieran? How integrated do you feel you are with your digital and grey infrastructure?
Well, the digital and smart infrastructure that we've rolled out over the last decade or so has given us an ability to redesign our whole concept of our CSO mitigation, and not just from a South Bend perspective, but we've kind of been able to do this and tell other communities about what we've done also. The different levels of success that we had so far was, we mentioned earlier about the idea about traffic flow in a city, and if you didn't have any traffic management, what kind of chaos would you have? And one of the first things we were able to do was just to manage the flow better and direct it to certain areas, or to allot the interceptor capacity to certain areas. But the point is that the smart sewer system was directly responsible itself for a lot of successes, but then inside of that, it was also responsible for successes of the grey infrastructure and their green infrastructure. For example, with our grey infrastructure, before we had the system in place, the smart sewer data, we thought that we had to build, the figure was something in the 35, 40 million gallons of CSO storage at 9 different locations, including many locations in downtown South Bend, which were, had a big social and community impact, as well as the financial impact on the community.
When you say CSO storage, could you just
tanks,
describe
basically
what that would
the idea?
look like?
Yeah, so like Stacia was saying, tanks, storage tanks. So just just capturing it, just kind of to some extent admitting defeat that you couldn't manage it any other way, and you're just bringing it in. You're building huge concrete storage basins underground to add more expense to it, and you're basically trying to capture that peak of the storm. And then once the storm has passed, then you're going to bleed that water, combined sewage back into your pipes, bring it to the treatment plant. But the problem with that was when we were designing that, and anytime you design a long-term control plan, you model and you try to predict what's going to happen when you get a certain amount of rainfall. But because we didn't have actual data from what had happened before our smart sewer system, we're making assumptions. So you assume 2 inches of rain is going to fall. Where's it going to fall? How much of that's going to make it into the sewer system? How much is going to get absorbed into parks and gardens and lawns and that? And then that which makes it into the pipe, then how much of that's going to stay in the pipe, or how much is going to make its way out of the pipe and go into the groundwater? So with any engineer, you're going to always make assumptions, but you have to qualify, because you don't want to get yourself in trouble. So you're going to say, well, I'm going to make this assumption, but I'm going to add 20% for safety, and then the next assumption adds 20% for more safety, and all of a sudden we're getting. The idea for our long-term control plan before we had enough data was that we needed to build $863 million worth of storage. And then when we went to finance that, basically we're talking about $1 billion of storage. Again, population of South Bend is 100,000 people. So that's $10,000 per man, woman and child. So a lot of money. So it was only after we were able to get the data from our system, put the system in place, gather the data over a couple of years, and then you can say, well, as opposed to what you might need, you can say what you do need, because over a couple of years you're going to have a variation of rainfall, and you're going to be able to say, well, rather than what would happen if we had 2 inches of rainfall, you can say what did happen. So therefore we were able to say, well, instead of those 9 pieces of infrastructure, we can actually build 3 pieces of infrastructure, but they're more appropriately sized because we've got the real data and the actual knowledge, and it's going to cost a fraction of that, about $250 million, so affordable. But the other thing then is that the smart sewer basically would have successes in itself, because it's able to reduce overflows, because you're able to allot the capacity better. But it impacts, like I mentioned, the grey infrastructure, but also the green infrastructure we found, because we set up, when we started to look at revising our long-term control plan, we set up a citizens advisory committee, and we tried to get a cross-section of our entire community in there. And we had some big business people in there who were just like, let's not spend anything on this. And then we had some very environmentally minded and concerned people who paddle on the river every day, and they wanted to spend a lot more money, and they wanted to say, well, let's do green infrastructure. And some communities have gone very heavily on green infrastructure, and that's great. But what we wanted to do was be very, very scientific about our green infrastructure. And we realized that if we just went out there and built green infrastructure for the sake of it, in most of the community, it wouldn't have any impact on our CSO at all. So the smart sewer data was able to tell us, the smart sewer system was able to say, there are specific areas in your system, you're actually in your town, in your city, where you can actually eliminate entirely a CSO activation going to the river. It'll tell you that there's some places in the city where just don't bother building green infrastructure, because the gap is so big between your overflow and your capacity that you're just going to have to build a tank or do something else. But we didn't know that before, and now we know. So now we know that we can build much less tanks. We can build green infrastructure in of 35 CSO basins, in other words, like the 35 little networks of sewer that we have in South Bend. We know that it'd be irrelevant to build green infrastructure in 26 of those, but in 9 of those, we know that green infrastructure will be massively useful. And then in 3 of those 9, again, we know that it can be like phenomenally useful, and it can totally eliminate any kind of activations, by which I mean overflow to the river. So, it's not just that the smart sewer does something in itself by being, smarter and directing flow, but it has a knock-on impact. That data is massively useful for all the other types of solutions that have been touted as green, as CSO solutions over the last couple of years. The grey infrastructure, which are the tanks and tunnels, and the green infrastructure, which is rain gardens, bioswales, all those kind of things. So it's a game changer across the whole community, the whole problem that it sees. So.
Yeah, no, I think it's important to reflect that the vast majority of sewer networks around the world are dumb. They have no monitoring in them whatsoever.
Yeah.
It's and making them even a little bit smart has incredible benefits, even just knowing what's going on.
It's like the old cliche of the low-hanging fruit. The success that you'll have initially is phenomenal. The first couple of months we had this, we've gotten pictures of the stuff that was in our sewer that we just had no idea. Before, you'd go out and you might say, well, you're trying to be democratic about how you clean the sewers. And you say, well, we haven't done this neighborhood, so we'll do this neighborhood. And then it's been 3 years since that one, so let's do this one. And then you're trying to do a little bit. But sometimes you go out there and you do some traffic management, you put out a couple of crews and you get nothing there, everything's fine. And then we wouldn't have known that in other parts we were really close to crisis. So the information of the first couple of months, just to be able to say, hey, the flow here is fine and the flow here is really bad. You've got a problem in this 300 yards between there. And we're able to target it and go out and find like couple of tons of gravel in your sewer, things like that, so easy solutions very early. And then of course, after the easy solutions, the longer you have the system in place, the more data you get, the more, 6 months of data is better than a month of data, and 6 years of data is better than 1 year of data. So with us, luckily, we've had a lot of data and we've been able to really mine that, and that's been hugely beneficial to us.
Yeah. I'm not sure that there's a limitless benefit to data and data. I think that there can be too much. And I know the utility I was based in London, we were generating far more than we ever used. I'd say that was too much, but I'm really pleased that you seem to have hit the sweet spot in South Bend. Okay, so I think what we've also talked about here is there's this, although Columbus and South Bend may not have necessarily faced this, or maybe you just overcame it, but is there a friction between traditional engineering approaches of that build bigger, kind of build more grey infrastructure, and the adoption of some of these digital approaches and smart infrastructure? Nicole, could you give us your thoughts on that, please?
Well, I think Kieran touched on it. It's always that conservatism. It's always that confidence level, because when you're designing something, it feels more comfortable to put on the 20%, extra, or the 20% extra here. And so you're kind of always against that. And not everybody has the data that some of these communities have. And the more you have, the more you can do with it. So I definitely think there's a friction between what is comfortable and what is maybe a little bit more challenging for a period of time. It's not easy to collect data in a sewer system. It's not. But it can prove very beneficial over time. So definitely friction.
Yeah, I think, over here in Columbus, we've tried to determine, the key to a successful implementation program here. And we found that it's, just to continually reiterate to all of our users of the system that, we actually developed these real-time controls and these tools that we're using now based on our system data, right? Like it's data we've been collecting for years. It's actual operating data. And, that data was gathered while we were putting in these operational constraints that we use in our system. So we're not pulling this information out of thin air. It exists, and we have decades worth of it. So it's true data that we're using to build this. Maybe it's not on a 24 by 36 plan set, and isn't dimensioned out like you would expect to see a traditional design, but it is useful information nonetheless. And one of the other key elements that we consider here when we incorporate these changes is getting buy-in with our users here in our system, those who are actually operating our system overall and really know it very well, better than most of us. So the way we're trying to do this is we're actually executing our program here in phases. So I'm saying real-time controls, but we haven't actually implemented them yet, right? We're developing them at this point. So this way, we enter this program in a phased approach, and that gives our operators that time to, cultivate this experience with the system, as well as gain that comfort with the data that's being developed for our future real-time controls. And a couple of the things that we've done here is we've actually built like a dashboard, an online dashboard that reports real-time feedback of, all of our settings in our system, all of the flows we're seeing in our system. And that provides a comprehensive location for our operators to monitor the system during wet weather events, and then communicate between the two plants looking at the same set of real-time data. And more recently, our dashboard is now showing predictions for the system. So these are tools that the operators can use to maybe tweak that adjustment or raise or lower that weir, make those changes in the system, and then see what happens. And that's just another way that we can instill that confidence in the system that we're looking to put in place. And then the other tool we have is what we've called the flight simulator. And it's a component that we've developed for our operators to actually run through system controls for a defined event, a simulated event, and then that will actually demonstrate to them the changes the things that they do in the system and the changes that will have on the system operation, but they're able to do so in a risk-free setting instead of, tweaking the system and then seeing what happens during an actual wet weather event. So,
Stacey,
yeah, go for it.
Just the point that you mentioned there a minute ago, we used to do that. Like we would literally have, weirs at the CSO, and somebody is saying, well, at 7 inches, no one complained about having the racement backed up. So let's bring it up to 8. And what happens? You could get 100 calls in the next week. You could,
Right.
So it was very, very real world, very dangerous kind of things. Whereas now with the ability to do things virtually, it's a lot better. Yeah.
What a great tool for operator training too, with the turnover the way that it is in our facilities these days. It's a great tool for that training and getting people up to speed.
Absolutely.
Yeah, I've certainly experienced the same thing, Karen, of tweaking a network or a pumping regime and just wondering what will happen. Kind of using best judgment is not necessarily the best way to do it, but it could also help with getting the buy-in of those operators, because some of these guys might be particularly skeptical over changing the way that you're going to run networks in the way that you've described.
And that's very real, though. It does happen, with operators at times, because people are nervous and anxious about change all the time. So luckily with us, when we made the change to this kind of smart source system, which is well over a decade ago, we just had the people in place at the time who were at the top willing to be brave and just try this out, and we're reaping the rewards now from the work that the last generation did. So yeah, but it does take a little bit of bravery to make that first step, because anytime a new technology is just different, and things that are different are just a little bit scary, so people should generally listen to the success stories that communities have had, and I think the sooner the better that other communities can do what we've done, the better, really, because you want to get that clock started on the time that you start gathering that data, because the quicker you start gathering the data, the quicker you'll be able to really do informed modeling. And that's our message to other people that we meet every so often, is just more do it straight away, get as many sensors in the ground as you can, gather as much information as you can, and you will just be able to make a huge difference to your system.
Which is a really nice sentiment. You just get started, and then it will work itself out for the problems that your city or your network has. And then there's a lot of power in data, obviously, and we spend an awful lot of time talking about, and indeed we all spend a lot of time generating a lot of data as well, which is used in so many different ways across smart cities already. Thinking about the future then, are there any things that have traditionally been considered as too difficult to solve beyond hydraulic overflow and CSOs that you're already thinking about how you might solve with smart solutions in your cities?
My experience is really everything is wet weather management for me. So everything that we've been trying to do is we have so much data, and that's great. And we've been able to mine that and have huge successes with it. And we have, like Stacey was saying about real-time control, we've implemented that, and we have got many locations around South Bend now where we have this real-time control. And it's somewhat easy to say, well, we've got a dozen locations and we can have these massive control valves that can be smart and that can open and close and that. But it's the scale is the next problem that we're looking to solve. How can we do this on a micro level, basically? How can we do it in on a street level, so that you can have smart catch basins that can open and close in relation to required rainfall, and managing that sweet spot of water on the street, so that you're not, the old solution when people were designing cities was just get the water away as quickly as possible. And now we're rethinking that. We're like, well, maybe not. Let's not dump it all, and let's not move it all straight away. Let's try and divert it and take the peak off that flow. And the other thing we're fundamentally trying to do is, our smart source system is all it's all about how much and quantities. But we want to be able to look at quality in future as well, and be able to say, make decisions based on not just quantitative decisions, but qualitative decisions too. So we can say, you know, not every flow is the same. You've got industrial locations, you've got different types of neighborhoods, you've got high density, you've got low density. So we want to be able to say, well, what's the difference in, you know, pick a parameter, pick E. coli, and say, well, right now the live E. coli from on this stream is X, and the other, and on this stream it's Y. So let's favor the one that's lower. And if we have to have an overflow, let that overflow, because the environmental impact is going to be less. So there's no end of ideas and opportunities, I suppose, really, for this kind of work for the next couple of generations. I mean, in the, you know, it's 2021 now. 2020, nobody was doing any of this kind of work. So we're writing a long-term control plan at the moment, and the dates we're talking about when we finish post-construction monitoring, we're talking, you know, 2040s. And you kind of think at the same time, we're like, gee, I'm going to sign off on this plan, and for 2040, where will we be by then? Hopefully we'll be way further down this road, and we'll be doing all sorts of cool, exciting things. And, you know, the hundreds of millions of dollars that we're spending, while less than the billions of dollars, maybe they'll be even less again, you know. So lots of opportunity and lots of very hopeful for the future of this kind of work.
Nice. Anything to add to those thoughts, Nicole, Stacia? Oh, here you go.
Yeah. I just wanted to add the quality over quantity thing, or getting to that quality aspect, both in terms of CSOs. I know we have a community in the Great Lakes right now that we're working on prioritizing those overflows based on the water quality impact, and how do you divert flow to say, okay, well, in this, you know, river basin that we're going to discharge to, there's less impact than this one over here, or this community would be less impacted. That's definitely something that we're going towards. But in Grand Rapids, even the sanitary flow, looking at your collection system and saying, this isn't just a trash can. How do we optimize what's coming to the plant in a true resource recovery aspect? How do we isolate those nutrients and be able to utilize them differently in the future, and have that sustainable effort going into that, and really look at it more holistically? So I think Kieran's right, quality over quantity, and we'll get there.
Very nice. Just give a last word to you, Stacia, if you'd like to make one.
Yeah, I mean, absolutely. You know, when it comes down to the way we've approached our plan, I mean, we did get to a point where there are some things that were just maybe too big for us to even handle. You know, we had constructed a pretty large, pretty long tunnel here in Columbus several years ago, and I believe that's what prompted us to take another look at things and work through this integrated plan, because we had several more of those, you know, on the horizon, and it was an expensive project. It was, you know, it took a long time, took a lot of effort. So, you know, there are solutions out there that are really too unwieldy and too expensive, and are going to take too much in the system. And that's, you know, that's what drove our focus in a different direction here in the city. And in doing so, and reviewing, you know, other options that we have out there, like these real-time controls and light green infrastructure, you know, we know that was a better way to address it overall. I mean, you know, here in Columbus, I mean, we adopted some great environmental policies back in 2005. Our mayor had put out this green memo and just wanted to make Columbus a better place to live. You know, and there were a lot of principles as a part of that memo that included stream and restoration, or stream and wetland restoration overall, and just focusing on our impaired waterways. So that helped drive our decision to maybe change the way that we think about things. And, you know, there were many activities that came a part of that. So it wasn't just what we were doing to reduce overflows. It was also, you know, removing low head dams in our rivers and returning streams to, you know, their natural flow and channels. So, you know, that's the best way to look at these. There's a lot of problems that are maybe too big to solve, but there's better ways to solve them and more holistic approaches out there.
Fantastic, thank you. Okay, so that brings our panel discussion to a close. I think it's been really useful and really interesting. It just demonstrates that digital solutions in wastewater networks can really be at the core of how they're operated and how we plan for their future as well. There's benefits to the environment, to the quality of life for citizens. I think really importantly to affordability of how we manage these systems into the future, being able to get outcomes that would previously not be deliverable without necessarily putting the burden of that on current and future generations. So I just thank the panel. Thank you all for your input. Yeah, as I say, it's been really, really interesting.
Thank you, everyone. Now we're going to open it up for Q&A. We're going to hand it over to Nicole and Stephen.
Thank you. So my name is Stephen Pandon, and I'm here joined by my colleague Nicole, and we're going to do the Q&A from the chat that you've been putting some really interesting questions in throughout the presentation there. So we've got some really tough ones. I'm going to start with something a little bit easier, and I'm going to direct this one to Nicole to start with. So William Brinson at Willis has asked us, what sort of exceedance notifications are generally provided to regulators when a sewage discharge occurs?
Okay, so it's mostly volume, I guess, for the most part. Most people would only want to give their notifications in the way that they have to, and oftentimes the water quality notifications are more, I guess, looked at more thoroughly through a true laboratory lens, EPA methods. And so they're probably not going to give those notifications in real time. However, it is possible, if you feel confident in your online analytical instrumentation, to give those notifications to your regulators. But they are very helpful to you as an operator as well. So I strongly encourage online analytical instrumentation and real-time notifications to your dashboards and how you operate and control your facilities, but oftentimes that wouldn't go directly to the regulator.
Cool. Yeah, no, here in Europe and the UK, it is again just the prevalence of monitoring equipment, and then that isn't always in place. It often isn't, and then the accuracy of that and the reliability of it can be challenging to keep to operate, and also understanding the context of those discharges and any harm that they do is something that's often done in a conversation with a regulator as opposed to with a notification. So it's quite an interesting question, and it leads us on to another one actually from Sean Dent. So the question here is, have we looked into the impact of water quality on receiving water? And if you have a CSO system versus having a separate sanitary system, is it possible to compare the two, essentially, is the question, particularly on things like suspended solids, BOD, metals, etc. So I mean, I'll pick that up to start with, and then I'll pass that one over to you, Nicole, as well for comment. There is an increasing trend, particularly in North America, of separating combined sewer systems, and the city that Nicole was managing before joining Xylem had that exact problem. And indeed, that's that same solution. In justifying that, it's not always going to be based on the direct water quality measurements and being able to price those in or to value those. So again, it's often done as a conversation between the utility and the regulator, and in some cases, as a result of some of the enforcement action that, say, in the US, the EPA will take against cities who are performing badly against their discharge performance. Is that a fair characterization, Nicole?
Yeah, I think so. Part of the question got to me is, were we looking at the water quality impacts when we were a combined system versus a separated, and can we tell the difference? And part of that is yes. We started sampling upstream and downstream in the tributaries in 1970, I believe. We had some pretty progressive thinkers in our utility and started sampling either monthly or quarterly from that period on, and we still do it today. And so there is that long-term look at water quality, and you can see a positive impact from the CSO separation. We all question whether putting stormwater straight to the river, like an MS4, I totally agree. It does have its impacts, but we were able to show ourselves and others that we did have a positive water quality impact. That being said, we have communities now that are looking at their CSOs and prioritizing those discharges based on water quality impacts and getting those real-time water quality information, prioritizing where we should manage the system to have a CSO that would have less impact in our community than maybe another place in our community and watershed. So definitely something that's being more looked at and more progressive.
Okay. So I was going to save one particularly difficult one. There's a question here from Sean on green infrastructure, but I don't think we'll have time to answer that one. So we're just going to jump to another one from William, which says, what's our opinions on the appropriate storm magnitude for design, 50 years, 25 years, etc.? So that's something that we've been speaking about a great deal over the past 10 years, or at least here in the UK, as the sort of the design standard here has always been 25 years, and it's been kind of creeping up to 30 years over time. And at the same time, the sustainability of those design standards is coming into question. So there's a great deal to be done on understanding where those design standards are likely to go with things like climate change pressures, but I think they're also going to become increasingly less relevant as we introduce things like the systems we've been speaking about today with South Bend and Columbus. When we think about the ability to build a slightly smaller piece of infrastructure, but that has more flexibility in terms of where or how wastewater flows through it, I think that makes the storm magnitude and the criticality of that in the design less important as we move forward and begin to digitize our networks more and more. Okay, so with that, I'll hand back over to Regina, and with our thanks from Xylem to WEF for hosting this today, and of course to all of our attendees. And thanks so much for all the questions. They were certainly challenging. I hope we did our best to answer them. Thank you.
Absolutely. This was great. Thank you, everyone, for attending today. This does bring us to the end of our session today. I want to thank all of our presenters and definitely our sponsor, Xylem, for sponsoring our presentation today. This actually concludes our e-showcase. The recording will be available at wefbuyersguide.wef.org. We will send all registrants an email tomorrow with this link, and please visit our event calendar to sign up for future webcasts.